Welcome back, my beautiful people, my grade 10s. Right, let's see if we can do some exponential equations. Okay, so when I say exponential equations, what do you think we're going to be doing? Right, exponential meaning exponents, okay, and equations meaning one side equal to another side. So your left hand side equal to your right hand side, and we're going to be dealing with exponents while doing equal side and equal side. Okay, so let's jump straight into it. All right, so if I give you something like this, if I say 2 to the power of x, okay, is equal to 2 to the power of 3. Okay, what is the only value of x, okay, that x can be so that this is true? Okay, if you don't know, let's just try some. Let's try some integers. All right, so if I've got 2 to the power of 1 equals 2 to the power of 3, are these equal? No. Okay, this is 2, that is 8. Okay, 2 to the power of 3 is 8. 2 and 8 are not equal to each other. Okay, let's try another one. If I've got 2 to the power of 2, is that equal to 2 to the power of 3? No, this is 4, this is 8. Okay, that's not equal. Right? Now, if I had 2 to the power of 3 equal to 2 to the power of 3, right? Does that make sense that this is equal? This is 8 and that's 8. Okay, so can you see that the only value for x is whatever this is? Okay, if I've got same bases, okay, that means that these exponents have to be equal to each other. Okay, so if I had something like this, x plus 1 equals 5 to the 2. Alright, I've got same bases. Okay, what does that mean about these exponents? These exponents have to be equal to each other. Okay, so over here, this exponent had to be equal to this one over here. So x had to be equal to 3 for this to be equal. Alright, can you see when it wasn't 3, it wasn't equal. Okay, so it has to be equal to whatever this is equal to. Right, so my exponents are equal when my bases are the same. Right, so bases are the same, 5 and 5. That means that my exponent, x plus 1, is equal to my exponent, which is 2. Okay, I know your teachers, some teachers teach dropping bases. Okay, we don't drop things in maths. Okay, you drop things at the gym. All right, we don't drop bases. Okay, we need to understand what we are doing. Okay, we do not drop things in maths. Okay, so you need to understand the logic. Okay, that means that my exponents are equal. Okay, so we've got x. All right, I want to solve for this x over here. So what am I going to do? I'm going to take all my numbers that way, all my x's this way. All right, so my x stays. Okay, when I take this one across, right, it becomes negative 2 minus 1. Right, we've got x is equal to 2 minus 1, which is just 1. All right, now how do I check if I'm right, guys? I take whatever I found my value of x to be, which is 1, and I just substitute it back into my question. Okay, so I've got 5 to the power of 1 plus 1. Is 1 plus 1 2? Yes, okay, so I've got 5 to the 2, 5 to the 2. Those are equal. I know that I'm right. Okay, so please always check your equations. Okay, it's very easy to check an equation. Okay, if you substitute this into your question and you get this side, left-hand side, equal to your right-hand side, then it's right. Okay, then you know you're right. You don't have to go back and retry or anything like that. Okay, it's easy to check these things. Okay, so let's get into some nice examples here. Right, so first thing always, before I look at anything, I always look for something when I'm dealing with exponents. Okay, I see I'm dealing with exponents, right? First thing I always have to do, what must I do? What must I do with my bases? Prime bases, okay? Prime, okay, please, prime bases, guys. Okay, always. When I'm dealing with my exponents, my exponent questions, okay, get those prime bases, all right? So 27 is not a prime base, but I know that it's 3 to the power of 3, right? In a bracket, and outside the bracket, x over 3, equal to 3 to the power of x minus 1. Right, I can still simplify here. Okay, what is 3 times x over 3? Okay, 3 times x over 3. Alright, how can I rewrite 3 as a fraction? 3 over 1. How do I multiply fractions? Top, top, bottom, bottom. And I'm going to get 3x over 3, which is just x. Alright, so I've got 3 to the power of x here equals 3 to the power of x minus 1. Alright, so now in this case here, okay, we've got same bases. Fantastic. What do I know about those exponents if I've got same bases? Those exponents are equal to each other. That means that x is equal to x minus 1. Okay, now how do I get the value of x? Alright, I'm going to take all my x's one side, leave my numbers on that side. Okay, so I've got x, take this x across here, and we've got minus x. Alright, and this becomes negative 1. Alright, now I've got an issue here because what is x minus x? 0. Okay, equal to negative 1. Okay, is 0 equal to negative 1? No, of course not. Okay, so there's something wrong here, right? So when this happens, guys, this does happen sometimes. That like maybe it's a trick question or a thinking question. All right. So when your x's cancel out like this and they give you 0, right? That means that there's no solution. Okay, no solution to this question. Okay, so this is what I mean. Let's check this. Okay, so let's pick a random integer. I'm going to pick 3 just for convenience sake. So if x is 3, okay, if you put 3 in here, you're going to get 3 over 3, which is 1. What is 27 to the power of 1? It's just 27. Equals, okay, is it equal to, is 27 equal to, if I place this as 3, okay, so I've got x is 3, so 3 minus 1. What is 3 minus 1? It's 2. And what is 3 to the power of 2? 9. Okay, is 27 equal to 9? No. Okay, so it, and trust me, if you put any value of any integer, okay, into the value of x there, okay, you're never going to get an answer where the left hand side is equal to the right hand side. Therefore, there's no value for x where the left hand side will equal the right hand side. So there's no solution to this question over here. Okay, so it's a nice question, right? So please always make sure that if your x's cancel out like this, okay, it means that there's no solution. All right. Okay, hoping that makes sense. Okay, so moving on, next example here. Okay, so first thing I do, I look at my bases. Look at all my bases. Okay, I see that there's a base there that isn't a prime base. Okay, so what am I going to do? Change him. Okay, so we've got 3x equals 3 to the power of 1 times 27 is 3 to the 3 in a bracket and x outside. Okay, let's simplify that. We've got 3 times 3 to the 3x and 3 to the x on that side. Alright, I want to get to one base on both of these sides. Alright, so what do I do? You guys know this already. What do I do with same bases when they're multiplying? Okay, this dot means that they're multiplying. So I've got 3, base of 3, multiply by base of 3. What do? I add those exponents. So here I actually have 3 to the power of 1 plus 3x. Remember in the previous video, okay, we were separating. We went from this stage and we separated into this stage. Okay, so now we're just going from this stage and we unseparating and we're going to this stage over here. Okay, so if you don't know what I'm talking about, go watch my previous video. You'll know exactly what I'm talking about. Okay, so we've got 3 to the power of x on this side. Okay, now I've got same bases here on both sides. So what does that mean? It means that my exponents are now equal to each other. Okay, so here I've got x is equal to 1 plus 3x, which is my exponents. Right, how do I find the value of x? I get all my x's to one side, all my numbers to the other side. Okay, so I'm going to take my x's this way. Okay, so it doesn't matter which way you take them, you always get to the same answer. Minus x, and that 1 is going to go across, so it becomes minus 1. Right, and what is 3x minus x? It's 2x, and minus 1. How do I get the value of x? I divide by 2 on both sides. Right, and x equals negative 1 over 2. Okay, if you want to change this around, you can also say x is equal to negative 1 over 2. I guess this looks nicer. Okay, but this is also right. Right, and if I take negative 1 over 2 and I put this back into here, okay, and I check in my calculator, I should get the same answer for my left hand side and my right hand side. Okay, so you do it separately. You do your left hand side, figure out what the answer is, do the right hand side, figure out what the answer is. If the answers are the same, you write. Okay, right, next example here. All right, let's look at this one. Pause the video, see if you can do it by yourself first, and then watch me do it. Okay, so I've assumed we've done it already. All right, so I see that I don't have prime bases. Okay, there's a prime base, here's not a prime base. Okay, how do I change it into a prime base? I say 125 equals, shift factor my calculator, and I get 5 to the 3 brackets outside the bracket, x over 3 is equal to 5 to the power of 2x. Alright, I can simplify on this side here. What is 3 times x over 3? Okay, 3 times x over 3. Okay, so that's 3 over 1. I'm going to get 3x over 3, which is just x. Okay, those 3's will cancel and I've got just x. Okay, so I've got 5 to the power of x on this side equals 5 to the 2x. Right, now I've got same bases on both sides. Right, so what does that mean? It means that my exponents are equal to each other. Okay, so I've got x is equal to 2x. Right, now how do I solve for x? Take all my x's this side, all my numbers that side, okay? But there's no numbers here, so I'm just going to take the x across. And I've got 2x minus x, okay? And on this side, I'm left with 0. There's nothing left on this side if I take that x across. Alright, so 0 is equal to x. Okay, so x is equal to 0 there. Now let's see if we write. Okay, so if I take 0 and I put it in here, what is 0 over 3? 0. Anything to the power of 0 except for 0 is 1. Right, and then we've got 5 to the power of 2 times 0, which is 0. 5 to the 0 is 1. Okay, both left hand side and right hand side are equal to each other. Okay, so I know that I am right. Alrighty. Right, moving on. Not the last example yet. We're almost there. Okay, so keep going. Alright, pause the video, see if you can do it by yourself, and then you can do it with me. Right, so firstly I see that I don't have prime bases. There's a 16, there's a 4. Okay, those are not prime numbers, not prime bases. Okay, so 16 as a prime base is 2 to the 4. Keep it in a bracket, x over 2 equals 2 to the 2 in a bracket, and we've got 2x minus 1. Right, let's simplify this a little bit. What is 4 times x over 2? So 4 over 1 multiplied by x over 2. Okay, it's 4x over 2, which is 2x. Okay, so on this side we've got 2 to the power of 2x. Right, and over here, guys, please, right, this is a very common mistake here. Right, this 2 is multiplying not only with the first term, but with the second term as well. Right, so here I've got 2 to the power of 2 times 2x, which is 4x. Okay, and 2 times the negative 1 as well, which is negative 2. Please, guys, that is a common mistake. If you did that, please NB this. This is very important. Right, people always make this mistake, and it's wrong, guys, please. Right, so I've got 2 times 2x, which is 4x, 2 times negative 1, which is negative 2. So please multiply with both terms there. Right, now I've got same bases. Fantastic. What does that mean? It means that my exponents are equal to each other. So I've got 2x here equal to 4x minus 2. Right, how do I find x? Take all my x's to one side, all my numbers to the other side. I'm going to take my x's this way. Okay, the reason why I'm taking it this way is because my 4 is bigger than my 2, so I'm not going to get a negative answer. I'm not going to divide by negatives. It's just nicer. Okay, it doesn't really matter which way you take it. Okay, so I'm going to take the 2 across this way. So I've got 4x minus 2x. This negative 2 is going to go across again, so it becomes positive 2. Right, and you've got 4x minus 2x, which is 2x, and 2. How do I get x? Divide by 2 on both sides. Okay, and over here, I've got 1 is equal to x. Okay, those 2's will cancel. Right, how do I check if I'm right? I take this 1, I substitute in here. Right, and if I get the same answer on the left as the right, okay, then I know that I'm correct. Right. Okay, hoping this is starting to sink into the brains. Alright, let's move on to the next example here. Alright, so first thing that I see there, I see a nice clue. Alright, I see something fantastic, I see something fishy. Alright, I see there's a plus. Right, so if you do not know what the alarm bells are doing right now, alright, you need to go and watch my previous video, please guys. Okay, alarm bells should be going off in your brain, alright, because we know what, when I see a positive and I see exponents, I'm going to separate, and then I'm going to get common factor. I'm going to get a bracket, simplify the bracket. Okay, let's see what's going to happen here. Okay, same deal. Okay, so we've got 3 to the power of x plus 2 times, let's separate here, 3 to the x times 3 to the positive 1 equals 63. Leave the 63 for now, we'll deal with him later. Right? Now, if I look at these two terms, okay, look at this first term, look at the second term, right, anything that looks exactly the same, yes, we've got the 3 to the power of x. If I take it out, 3 to the power of x, what's left? We've got 1 left here, plus, what's left here if I take it out? The 2 times the 3. 2 times the 3. Not 2 comma 3, 2 times 3. Equal to 63. Right, let's simplify this bracket. Right, so you've got 3 to the power of x, bracket. Okay, what am I going to do first here? Am I going to do addition first or multiplication? Multiplication first because of BODMAS. Okay, BODMAS. Okay, so 2 times 3 is 6. 6 plus 1, 7. Equals 63. Alright, I want to get this by itself. Okay, I want to get this 3 to the power of x by itself. I want to isolate that term, or that thing over there. I want to isolate it on by itself. Right, but I see that there's a 7 attached to this. How do I get rid of the 7? I want to get rid of him. I don't want him there anymore. Alright, I'm just going to, because this is being multiplied, how do I get rid of a multiplication? I divide, I do the opposite. So I'm going to divide by 7 on this side, and I'm going to divide by 7 on this side. Okay, when I divide, I do it on both sides. Okay, I do something on one side, I do it on the other side. Okay, so those 7's will cancel out, and I'm left with 3 to the x. I'm isolating it because this is where my x is, and I'm solving for x. Alright, so what is 63 divided by 7? It's 9. Very good. Alright, quick maths there. Alright, I still don't have same bases here, guys, so there's a bit of an issue. Okay, a bit of an issue. Alright, so how am I going to get same bases here? Right, I can change 9. Okay, so 3 to the x is equal to 3 to the power of 2. Fantastic. I've got same bases now. So what does that mean, guys? It means that my exponents are equal. That means that x, okay, is equal to 2. Right, and if I want to check this, I substitute x in this left-hand side here. If this left-hand side gives me 63 when I substitute in 2, then I'm right. Alright, so go check that. Right, we're going to go straight into our next example here. Okay, so ding, 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 ding. I see that there's a minus there. Okay, alarm bell should be going off. What are we going to do? separate, common factor, simplify brackets, and do things. Okay, so let's see what's going to happen. All right, so I see that I've got 3 to the power of x plus 1 there. What am I going to do? I'm going to separate it. So I've got 3, the x times 3 to the 1 minus 3 to the x equals 162. Alrighty. Okay, now here, now I look at my first term. Right, I look at my second term. What is common in those two boxes there? Right, can you see that the 3 to the x is the same? I'm going to take it out. What's left there? 3 minus, okay, 3 is left, minus now in this term, what's left? 1 bracket equals 162. Fantastic. Okay, I want to simplify this bracket, so I've got 3 to the power of x in a bracket, 3 minus 1 is 2 equals 162. Right, but I want to isolate what I'm solving. I'm solving for x. I want to isolate it. Okay, so how do I isolate it? I divide by whatever is here in front of it or behind it or whatever's attached to it. Okay, so I'm dividing, okay, because this is multiplying with each other. So to cancel that out, I'm going to divide by 2, cancel those, divide this side by 2. Okay, that's going to give me 81. It's going to give me 3 to the power of x. Right, I don't have same bases. What am I going to do? I'm going to get my calculator out and I'm going to put 81 in, equals, and it gives me 3 to the, and shift in fact, and I'm going to say 3 to the power of 4 and 3 to the x. Right, I've got same bases now. What does that mean? Beautiful things. I know that my exponents are equal to each other. Okay, x is equal to 4. My exponent here is equal to my exponent there. Alright, fantastic things, right? Alright, isn't it just lovely? Alright, okay, so pause the video, okay, sink it in, let it soak, alright, and let's go to the next example. Alright, so, next example here, okay, first thing I see, okay, I see a minus, ding, 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 alarm bells are going off, alright, because I know I'm going to separate. I'm going to get a bracket. I'm going to simplify. I'm going to do things. Alright, so let's see what the things are. Alright, so I'm going to separate. First thing I'm going to do, boom, boom. Alright, minus, boom, boom. Separation, okay? Divorce those terms. Okay? 120. Alright, so now I look at my two terms here. Look at the first one. Look at the second one. Anything that looks exactly the same, guys. Only the stuff that looks exactly the same. Exactly the same. Alright? Awesome stuff. I see that it's 5 to the x, 5 to the x. Okay, so I take it out. 5 to the x. What's left here? 5 to the 1. Minus. What's left here? If I take out 5 to the x. 5 to the negative 1. Alright. And that's 120. Alright, then I'm left with 5 to the x. Let's simplify this bracket. Okay, so what's 5 minus 5 to the negative 1? I don't like that. Okay, what am I going to change that to? 5 minus 1 over 5. Okay, alright, equals 120. Okay, and what is 5 minus 1 over 5? Okay, that's 24 over 5. Right, in a bracket, I'm left with 5 the x. Okay, right, and that's equal to 120 over there. Right, now I check myself and I see there, right, I see that I want to isolate something. Okay, I want to isolate what? I want to isolate this 5 to the power of x there. Right, so I want to isolate him. So how am I going to isolate that? I need to, very good, I need to divide by whatever is multiplying by this 5 to the x. And what's multiplying there? Okay, it's the whole of 24 over 5. So I'm going to divide by 24 over 5. Okay, I can't just do it here. I need to do it on this side. Okay, but here I'm not going to say divided by 24/5. I'm going to say divided by 24/5 because it just looks nicer. Okay, divided by 24/5. Okay, I can actually do it on this side as well, so I can have some more space. Oops. Okay, so if we, let me just fix here. Okay, 5 to the x, whatever, it's in a different color now. Okay, 24/5. Right, I'm going to divide, okay, by 24/5 on this side as well. Okay, so those are going to cancel. Okay, and here, change my color now. Okay, so here I'm left with 5 to the x. And what is 120 divided by 24/5? Good. Okay, it's 25. All right. So I still don't have same bases there. So what am I going to do? Okay, don't have same bases. So I need to change the 25. All right, so let me go up here because I'm running out of space. All right, so 5 to the x is equal to 5 squared. Right, same bases. What do I know about those exponents? They are equal to each other. All right. Okay, guys. So I hope that this video was helpful. Okay, these are some exponential equations. All right, so please rewatch this video if you don't understand anything, or yeah, do some more examples and just keep going, guys. Just keep pushing hard. All right, you guys will pass grade 10 with flying colors. Okay, all right. So please go and do some more examples of these. Maybe even rewatch the video. And I hope that you guys are ready for your tests and your exams. And yeah, just good luck, grade 10s. Okay.